Alrighty, folks, in this video, we're going to be talking about functions here. So this video is really going to give kind of an overview of what functions are, where they're used, and how they can be represented, and how they usually are represented in mathematics. So here's just a kind of a general understanding overview of functions here. So what a function really is we have a collection of what we call input and output values. So we see here on the left we have these input values. So they're going through some, it's kind of almost looks like a machine here that's doing something to our input values, and then it's kind of spitting out these output values. So that's kind of a general idea of what a function really means. In mathematical terms, right, this is going to be some number inputs, and then something's going to happen to that number, and then some output is going to give possibly a different number. So to be more specific, the input values are sometimes called what is the domain. So you might see it called that. What this means is just talking about the input values of our function, right? So that's what we're calling the domain. And our output values then also have its own special name called the range here. So that's our range is our output values, right? So you might see these words, really what they mean are inputs and outputs into our function. Numbers we're putting into our function and the numbers we're getting out of that function. So in this video, we're going to be talking about three separate ways of representing functions. So firstly, we're going to talk about functions as equations. And then we're also going to talk about functions as they're represented by tables. So it'll be like a table of values. And then also functions as they're represented graphically on a graph. Right? So we'll see those three separate ways of representing functions. So if you're particularly focused in one of those ways, you can go ahead and skip forward ahead the video to that point. Before we start by talking about any of these, we're first going to look at what's called function notation. So there's a certain notation that we use with functions. Probably you may have seen this before. So this is what looks like this kind of curvy f parentheses x. Right? So this is our function notation. What I mean by notation is this is representing function, right? So the f here, the f stands for function, right? And so this is pronounced here, f of x. So we say f of x. That's how this is said here. This is s parentheses x is f of x. And so what this is meaning here is it's saying the function at the value x, right? So in this case, x is my input value into this function. F is my input value into this function, into the function f, and that's going to give some output value. So the whole f of x here is my output value. So that is my output value. So x is my input value. It doesn't have to be x. It might be some other variable. It could be f of a. Could be f of any other variable we put in there. But so this is our input value into the function. F of x is our output value. Okay. So now we're going to look at what this means as an equation. So this is best to look at kind of an example to help us understand this here. So let's look at an example. So an example, f of x, let's say f of x is equal to 2x plus 3. Okay, so this is an example of a function. Our input values, of course, here are x, that's our input values. And our output values, so to get our output values, it has to go through that function as we saw here. So this 2x plus 3, this is our function, right? Where this statement is defining 2x plus 3, that expression, to be our function. That's what this f of x is equal to means. It's defining this as our function, right? So the 2x plus 3 is what's happening, what's changing that input value. And so the result of that is going to be what our output value is, okay? So let's see an example of this. So let's say our input value here was 1. So I have an input value of 1. So we would write that as f of 1 here. So what this means is I'm replacing my value x with my value of 1. So I'm saying that input value is 1. So I'd write 2 instead of x here now. I would write times 1 and add on 3, of course. So now going through our algebra here, f of 1 is, of course, 2 times 1, which is 2. You add 3 to that and you get 5. So now we get this statement down here. And this says f of 1 is 5. What this really means is looking at this function f of x here. At an input value of 1 gives me an output value of 5, right? So this is kind of this combined connection here between my input and output values. This is giving me kind of a pair of values, 1 and 5, 1 giving me an input value and 5 an output value. So this is how they're kind of represented as equations. They look kind of normal to what we would see a regular equation be. That might be written in a y equals form instead of an f of x equals, but really we're talking about the same thing here. This is just telling the reader that this is a function that we're talking about, not just any old equation, but actually a function. So let's go ahead and take a look now how this can be represented as a table of values. So we'll look at a table of values here. A beautiful table of values here. So we have our x values and we have our outputs. Usually we would say x and y, right? But here we're going to say f of x. In this case, f of x is kind of standing in for that y. So let's say our x values are 1, 2, and 3. Corresponding f of x values 4, 5, and 6. So this is another way to represent a function. At the input value, so these are my set of input values here. So x is my input still, right? Then f of x is my output values, right? My output values. So what this is saying here is it's giving us those pairs. So that pair that we saw before, we're now given a few of those pairs. So we have the pair 1, 4 here. What this is saying is an input value of 1 gives me an output value of 4 in this function. Okay, and then likewise an input value of 2 giving me an output value of 5, input value of 3, and output value of 6. And so now we can kind of identify what's happening, what function is changing these input values to get these corresponding output values. And of course we can see here, right, in order to get from 1 to 4, well, that would be to add 3, right? And to get to 2 to 5, well, that would also be to add 3, and same thing here, 3 to 6, I would have to add 3. So we see each time, what is the function doing? What is this function f of x? F of x is taking my input values here, so my input values, of course, being x. So f of x is taking x, and each time it's adding 3 to get the corresponding output values. So here we would say f of x is x plus 3, right? This is what the function is doing. This is what it's changing the input values to get those corresponding output values. So we can see the connection here between how functions are represented through table of values and how they're represented through equations. Last step here, we're going to see how functions can be represented as a graph. The kind of xy coordinate plane. Well, of course, instead of x and y here, we know our input values are x, so that's going to be on that x-axis. And our output values, of course, are now our f of x. F of x. All right, so now we might have some function. Let's say it looks something like this. So we see our input values and our output values, they're still here. Right? So they're still here alongside. It's just a visual representation of functions here. So now I might be able to, let's pick any input value. So I can pick, let's say these are counting by ones here. So this would be an input value of 3, right? And of course, we can see that corresponds to this value on the graph right here. That's when x is 3 on my graph. This corresponds to an output value, an f of x value, that's also 3. So here we would say, of course, our function has that ordered pair at the point 3, 3. So we can see kind of multiple ways of representing the same sort of idea. All of these are representing functions. If anyone has any particular examples they'd like to see of how to solve for functions, how to graph functions, or describing functions, feel free to leave those in the comments section down below.